Today we start the last topics in chapter 4 that are outside of our notes. We're going to look at reciprocal functions and absolute value functions. So this is going to be sort of similar to, remember in chapter 2, remember in chapter 2 when we graphed all the square root graphs and said if we can graph the inside first, then we can graph any square root of any inside by making all the zeros the same, all the ones the same, and learn some techniques like between 0 and 1 it was slightly above, and after 1 it was below. So we learned a special type of graphing, which was y equals the square root of f of x. Today, we're going to learn the special type of graphing of if you put any graph on the bottom, how could you graph the reciprocal of that? Now, one of our parent graphs that we did at the beginning was 1 over x. But now, we can do 1 over sine x, 1 over log x, 1 over any function. So what does that mean? Okay, first of all, 1 over f of x is not the same as f inverse of x, the inverse function where you switch the x and y and solve. 1 over f of x is the reciprocal function. So what we have in the notes that I handed out is some instructions and then some examples. All the extra. So first of all, if you're going to highlight, basically the only rule is that if you have y equals 1 over f of x is a y value, so all you're doing is you are changing your y values that you currently have to 1 over your y value. So if you had any point x comma y, it now changes to x comma 1 over y. And that's the only rule, and I can tell you that rule, we could be done right now, but the graphs turn out really weird as a result. So there's some characteristics that we need to look at. What happens if the only thing you do is change y to 1 over y? What happens to the graphs? Well, we have a couple of things here to look at. First of all, if we are graphing this, we're going to graph, just like the square root graphs, inside the square root graphs, we're going to graph f of x first. So whatever's on the bottom is going to be something that you already know how to graph. Sometimes on the exam, they just give you a graph. So first of all, we draw f of x. And then the first thing that's going to happen that's interesting is that you are going to have vertical asymptotes at all your non-permissible values. Because it'll never cancel out with a 1 on the top. Does that make sense? When you have a non-permissible value and it cancels out, then you have a hole. But if you have a 1 on the top, your non-permissible value is never going to cancel out. So all of your non-permissible values are going to turn into vertical asymptotes. And all of your non-permissible values are going to be where the original function has x-intercepts. Does it make sense that if the bottom has an x-intercept, that means its y value is 0. Then if you do 1 over that, then you would be dividing by 0. So this is step 1 when graphing reciprocal graphs. You're going to see if your original function has any x-intercepts, because those will be non-permissible values, and then you'll have a vertical asymptote. If your graph goes to positive or negative infinity, that means the degree is going to be bigger on the bottom than it is on the top. And just like our rational functions unit, if the degree is bigger on the bottom, you're going to have an asymptote at y equals 0. And this explains, in these notes, I also have the explanation why. Like if you take a point where the y value gets really, really big, then if the only rule is you change change your y value to 1 over your y value, it's going to get really, really small and really, really close to 0. We're going to change, sort of keep with the theme that we've been doing all year. Just put above number 4. Find as many nice points as possible. And all you're going to do is change the y value to 1 over y. And some nice points in particular are where the y value is 1. Because if you would do 1 over y, you get 1 over 1, and it would stay the same. Same thing happens with negative 1. So once you have your asymptotes and a few nice points, just like graphing rational functions unit, now this is also still nice points. 4 and 5 are just talking about nice points. In number 5, it says if you have a maximum in a graph, when you do the reciprocal, that's going to become a local minimum. Because when you flip the y values, they're going to change that way. Like the highest point, 1/8. If I had a highest point of 8, I do the reciprocal, I get 1/8. A lower point of 4 will be 1/4. 1 will be 1. So the maximum points will become minimums, and minimums maximums. And then finally, once you have a bunch of nice points, then we just draw our graph towards the asymptotic behavior. Towards the asymptotes to show the asymptotic behavior. So in each of the handouts, what I've done is I've given you a bunch of examples that are already done, and we're just going to walk through them so that we can go through them a little bit quicker. Some of these you could do with your rational functions unit, chapter 2. So for example, number 1, you could do using chapter 2. You would factor the bottom to be x plus 2, x minus 2. And you would tell already that you have non-permissible values, that x can't equal 2, and x can't equal negative 2. And from chapter 2, you would say they didn't cancel out, they're not going to be wholes, so we would know that there's going to be vertical asymptotes. Now, our new technique for this unit, which is going to allow us to graph anything on the bottom, says first draw the bottom. And I'm going to just overlap it here. You have this on yours as well already. If I graph x squared minus 4, I'm going to have a vertex at 0, negative 4, because that's just a parabola shifted down 4 units. I'm going to have x-intercepts at negative 2 and at 2. And what I'm going to do is, in the notes, I did each step separately, slowly, but I'm going to draw it beside here so you can follow the steps, but all on one graph. So if you graph the bottom function, your non-permissible values are going to become asymptotes, just like in chapter 2. So I'm going to go to 2 and negative 2 and draw vertical asymptotes. For reciprocal graphs, we say if our original graph goes off to positive infinity, see how it gets bigger, or off to negative infinity, either one, you will have a horizontal asymptote at y equals 0. From chapter 2, we would have known this as well because the degree is bigger on the bottom of the function. Okay? But for this unit, sometimes they just give you the graph, and you don't know what the equation was. So now, we're using the idea that since this blue graph goes up forever, those y values are getting bigger and bigger and bigger and bigger. And if I do 1 over my y value, once the numbers get huge, 1 over a huge number gets closer and closer to 0. So now we've got both of our asymptotes done. Steps 4 and 5, let's just find a bunch of nice points. Like here, I have 0, -4. If the reciprocal graph, all it does is take your y values and change them to 1 over y, this is going to change to 0, 1 over -4. And I can find another point on my original graph. For example, I could plug in 1 and I would get -3. So on my reciprocal graph, I would have 1, 1 over -3. All that's happening to your points is you're taking your y value and changing it to 1 over your y value. The other thing about reciprocal graphs is when you have a 1 on the top, does it make sense that there will never be any x-intercepts? Because the only way a fraction is equal to 0 is if your numerator is equal to 0. So once I have these points, well, I know that it has to go towards the asymptotes. I know there's no x-intercepts. I would be able to say that that section looks like that. Have I graphed all the sections? No. You see there's a section here, section 1, there's a section in between, which we did, section 2, section 3. So I would go to my original graph, I'd say, if I plugged in 5, or no, sorry, I'll plug in 3. 3 squared minus 4 is 3, 5. That means on my green graph, I'm going to have 3, 1 over 5. Because all you do is take your y value and change it to 1 over. Then we have a point in this section, and just like chapter 2, and same thing over here, if I plugged in -3, I'd also get 5 on my original, so I'll get -3, 1 over 5. And that's enough to draw that section. So very similar to chapter 2, reciprocal graphs, but we're going to find out that we can do the graph of anything. So something, and we'll do a couple more. We're going to graph 1 over x squared plus 1. Notice here the bottom function, I'll draw here again, has a vertex at 0, 1, because you just need to draw a parabola with a vertical translation up 1 unit. And this one has no non-permissible values. You can never make the bottom equal to 0. And you can see it in the graph, that in the graph, the blue one has no x-intercepts. So when drawing our reciprocal graph, step 1 was to draw vertical asymptotes, but this one doesn't have any vertical asymptotes. Step 2, look at your graph. Does it go off to infinity? Does it go up forever or down forever? It does. It goes up forever. So we will have a horizontal asymptote at y equals 0. Based on this, we can start doing some nice points. So let's look at a couple of points on our original graph. I've got 0, 1. Can you see when you flip the y value, that's still going to be 0, 1. I mean, technically I could write 1 over 1, but it's still the same thing. I take another point on my blue graph. Like, for example, if you plugged in 1 squared plus 1, you get 1, 2. On my reciprocal graph, I'd have 1, 1 over 2. If I plugged in 2, I'd get 2, 5. And on my reciprocal graph, I get 2, 1 over 5. And similarly, I'd have the same points on the other side. If you did this graph in grade 11, sometimes the teachers call this the speed bump graph. So it looks like a little speed bump. You didn't do this in grade 11, well, what introduced you to the speed bump? this is why reciprocal graphs are interesting, because this was 1 over a parabola, and this was 1 over a parabola, and the two graphs are completely different looking in the end. So one of the challenges with reciprocal graphs is you don't know what they're going to look like until you go through the process. And the process is always to find your asymptotes first, then a bunch of nice points, and draw your graph towards the asymptotes. Once again, there's no x-intercepts. And we just had, after we did a couple points, it became obvious how we could draw our graph toward the asymptote in the end. Again, this one could have come up in chapter 2 as well, 1 over a parabola. But in chapter 2, we never did 1 over square roots. We never did 1 over cube roots or 1 over x cubed. So now we have some new graphs that we're going to do 1 over. But the process or the steps is the same. So first, again, I'll do it in blue. I'll just draw over top of this first one. We'll regraph the bottom. And usually something that's on the bottom is something you've already graphed this year already. Could be a logarithm, could be a sine. This is why this is a nice chapter to end with, because it reviews your first chapter and a bunch of graphing all throughout the whole year. So how would I graph the square root of x plus 4? I would probably take my square root graph and move it 4 to the left. If I get negative 4, here's the 3 key points of your square root graph, and move it 4 to the left. You could also use chapter 2. Remember in chapter 2, you could graph the inside x plus 4, and then see where it's equal to 0 and 1, and do some nice points and graph it that way as well. Now right beside, we start with, are there non-permissible values, right? This one definitely has a non-permissible value. It has actually quite a few non-permissible values. But if we think about where it's equal to 0, for sure x can't equal negative 4. We see that as an x-intercept on our graph. We also see that x can't equal, how would I write this? Maybe I'll just write the domain. Oops. The domain of this graph is that x has to be bigger than 4. Anything bigger than negative 4, sorry. Anything less than negative 4, and you can see it on the graph, doesn't exist. Why? Because we also can't take the square root of a negative. So there's a lot of non-permissible values, but in particular, we're going to look at the x-intercept at negative 4 and draw a vertical asymptote. Does the graph go up forever? It does. Square root graph keeps getting bigger and bigger, slowly, but it does keep getting bigger and bigger. This arrowhead here is telling you it's going forever to the left and also going forever up. The only way you could tell if it doesn't go forever up, there would have to be a horizontal asymptote above it, but we know that there's no horizontal asymptotes on a square root graph. So we're also going to have a horizontal asymptote at y equals 0. Next, we find some points, like we have negative 3, 1 and 0, 2 on our original graph. 0, 2 will change to 0, 1 over 2. Negative 3, 1 will change to negative 3, 1 over 1, which I could just leave as 1. If I wanted to find another nice point, for example, here if I plug in 5, 5 plus 4 is 9, square root of 9 is 3. I would have the point 5, 3 on my original graph, which means on this graph, I'm going to have 5, 1 over 3. So if you can graph the bottom When you're doing a 1 over graph, all that's changing is your y values are changing to 1 over y. It's a pretty simple rule, but the graphs look different every single time, so we have to know the simple rule in order to be able to graph. So there's our final graph of 1 over a square root graph. And this is very typical of the exam. So on the exam, they actually make your job easier. Because in the first 3 examples, we always, in blue, had to draw the graph on the bottom first. On the exam, they're like, we give you the graph on the bottom. The blue graph that we've been drawing first every single time, they're saying, here it is, given to you with an arrowhead on it. And you have to draw the reciprocal graph. But you don't have an equation. So you can't see your non-permissible values from your equation. You have to see the non-permissible values from the graph. And what can't you divide by? You can't divide by 0. So we look on this graph, and I'll highlight this in red. We have 3 points where you have x-intercepts. So on your reciprocal graph at -1, at 2, and at 5, you're going to have vertical asymptotes. So wherever you had x-intercepts on your original graph, that's where your y values are 0, and then on the 1 over graph, you can't divide by 0, those will become asymptotes. Next, do we have a horizontal asymptote? Well, we'll have a horizontal asymptote if our graph goes up forever or down forever. And in this case, we have an arrowhead saying if it's going up forever, so we will have a horizontal asymptote at y equals 0. Finally, nice points. -5 comma -1 is going to change to -5 comma 1 over -1, which I wouldn't have to change because that would stay the same. Same thing, -3 -1 is going to stay the same. You see the straight line here will end up being a straight line there. But now it has to go towards the asymptotes. 1 over graphs never have x-intercepts, so it can't go up. It would have to go down. You could also take, oh, I want this. Sorry. We should have final graph. Green. So it has to go down. Now we could have taken another point on here. It looks like at, well, this is negative. That's at -2. This is -5. Here's 5. I could pick on my original graph another point here. It looks like at -1.5, I have -1/2 on my original graph. What's going to happen to that point? You're going to get -1.5. And what's the reciprocal of 1/2? Well, the reciprocal is just flipping a fraction. You could do 1 over 1/2, but divided by a fraction means multiply by the reciprocal. All that's going to happen to that half is that -1/2 is going to change to -2. And so that also explains why it needs to go down rather than going up. In the middle section, we have 0, 1. That's going to stay 0, 1 over 1. And this section will go up. And one of the things that we had in our notes before is that in a section, if you have a maximum in that section, which we do at 0, 1, that becomes the minimum of your reciprocal graph. So maximums become minimums, minimums become maximums. Same thing with 4, 4, negative 1. That's going to become 4, 1 over negative 1, which stays the same. And that is a minimum here. It's going to become a maximum in that section. And finally, 6, 1 will become 6, 1 over 1. Some things to be careful on with this graph. Okay? Right here, your original graph stopped. So your reciprocal graph has to stop. But this asymptote here is going, it's going to be like, you're going to see that asymptote and you're like, I draw things towards asymptote. You're going to be tempted, you're going to be tempted to do this in purple and keep drawing it and add an arrowhead. Can you see yourself seeing the asymptote and just saying, I draw towards asymptotes, and you just keep going? If this graph stops, your graph has to stop. So you can't just add an arrowhead if the original graph. So that purple part, we have to get rid of. There we go. Tempting that you'll make it want to keep going. So they like to do that on the exam to see if you're paying attention. But all the other place, you need to show it going to your asymptotes. So, I have a little worksheet here for you to work on some graphs. And in part 1, you have to graph them first and then do the reciprocal. In part 2, the graphs are given to you. And you can draw the reciprocals right on top of those graphs. Okay?